My name is Dr. Rajeev Kumar Chauhan. I am a senior member of IEEE. I have done PhD from Indian Institute of Technology, Mandi. Currently, I am working as assistant professor with the Department of Electrical Engineering at Galgotia College of Engineering and Technology, Greater Noida. I am a former research scientist with University of Manchester, United Kingdom. Today, I am going to discuss about the digital logic design, and in this especially I am going to discuss about the access code addition. In my previous lecture, I have discussed about the Excess-3 code and why this is different with the as compared with the binary and the BCD codes. So, in this code, whenever we are talking about the Excess-3 code, so first of all we will convert any decimal number to the BCD code, which is a 4-bit code. For one BCD code, in the BCD code we represent a 1 decimal bit in a 4-bit binary number, and that is the weighted so for BCD is actually 8421. These are the standard weightage for the 4 digits, like for if we have a BCD code 1111. So, the weight of for this one will be 8 plus 4 plus 2 plus 1 is equals to 15. So, if we want to convert this BCD code to the Excess-3 code, so we have to add the binary equivalent of 3 decimal number. So, for example, here we want to add the 2 and 5 using Excess-3 code. Okay. So, first of all we will convert both the numbers into the BCD. So, the BCD equivalent of 2, from here we can see the BCD equivalent. If you want to represent the decimal number 2, then we require this digit should be high and remaining 3 digits should be low. So, if we will write down, it means if these digits are low, it means it will become 0, it will become 0, it will also become 0. So, the final equivalent will be 2 decimal of decimal. Okay. So, the BCD equivalent for decimal number 2 is 0010. Now, if we want to write down the BCD equivalent of 5. So, from here we can see if you want to represent the 5. So, we required 5 could be 4 plus 1 or 2 plus 2 plus 1, but here we have only 1 2. So, it means we have to use the 4 plus 1. We know 5 is equals to 4 plus 1. So, this 4 digit will be high, 2 will be low, this will be high, this will be low. Okay. So, this is the BCD equivalent of 5. So, that is why I have write down BCD equivalent of 5 is 0101. Okay. Now, as per the question, we want to add these numbers 2 plus 2 and 5 using Excess-3 code. So, now we have to convert these both the numbers into the Excess-3 code. So, to convert the number from BCD to Excess-3 code, we have to add the binary equivalent of 3 in both the numbers separately. So, for example, here I want to convert 2 into the Excess-3 code. So, to convert the Excess-3 code, this is the BCD code and this is the binary equivalent of 3. So, we can add 3 here. So, 30011, because from here we can see if the code is if the code is 8421 weighted code, BCD is a weighted code. So, if you want to represent the 3, it means 2 plus 1 and remaining digits will be low. So, this is the binary equivalent of 3. Okay. Similarly, we will add binary equivalent of 3 in the 5, then we will get the Excess-3 code. So, this is the Excess-3 code for 2 and 5. Now, we want to add these two numbers to get the Excess-3 code of 5 plus 2. So, what will we have here? So, we will add these two digits 1 plus 0. We know in the binary number system, binary number system, 1 plus 1 is equals, sum is equals to 1 and carry will be 1, sum will be 0 and carry will be 1. Okay. 1 plus 0 or 0 plus 1 will be equals to 1 and carry will be 0. Okay. So, from here we can see this is 0 and we want to add with 1. So, 0 plus 1 is equals to 1. So, that is why I have write down 1, 1 plus 1, 1 plus 1. So, from here we can see 1 plus 1, the sum will be 0 and carry will be 1. So, sum will be 0 and carry will go here. Then 1 plus 0 is equals to 1. From here we can see either 0 plus 1 or 1 plus 0, both in both the cases the sum will remain 1 and carry will be 0. So, we will get the 1 here, and in this all the in this column all the elements are 0. So, we will get the 0. Similarly, for 5, 1 plus 1, 1 plus 1 we know from here 1 plus 1 sum will be 0 and carry will be 1. So, 1 plus 1 the sum is 0, then 1 carry will be generated, this carry will go here, 1 again 1 plus 1, then the sum will be 0 and carry go here. So, 1 plus 1 further, then we will get the sum is 0 and carry is sum will be 0 and carry will be 1, carry will be produced. So, this carry will go here and 1 plus 0 from here we can see it the sum will be 1. So, that is why the sum is 1, but this is the so, when we will add these are the Excess-3 code for this is for 2 and this is for 5, but in our question we want to add 2 plus 5, it means we have to add these two codes. Okay. So, when we will add these two numbers, so the number is 0 1 0 1 and 1 0 0 0. So, we will add these. So, 1 plus 0 is equals to 1, 0 plus 0 is equals to 0, 1 plus 0 is equals to 1 and 0 plus 1 is equals to 1. So, this is the code we get after adding the Excess-3 code of 2 and 3, 2 and 5, but this is not the final answer. Why this is not? Because from here, from this section we can see Excess-3 code represent the 3, if we will add the 3 in the BCD code or any decimal number, we will get the Excess-3 code, but from here we can see what is the value of this one. So, this is 1101 and this is 8421. So, from here we can see 8 plus 4 plus 1 is equals to how much? 13. Okay. While we know 2 plus 5 for the decimal number system is 7. Okay. So, 7, if we will subtract from 7 here, then how much this is? This is 6, 06. Okay. So, we get the equivalent is of 13, but 13 is not the Excess-3 code. The Excess-3 code represent the whatever the sum is, the if we will add the 3 in the decimal number, we will get the Excess-3 code. But in this case we can see if we are adding the 6 in the decimal sum of the decimal numbers, we are getting the some code. it means this is the Excess-6 code, and we can verify from here we have add 3 2 times, 1 times in the 3, 1 times in the 2 and second times in the 5. It means we have add the 6 in this question. So, that is why we are this is not the Excess-3 code, we are getting the Excess-6 code, and that is the right answer. If we will add the 7 plus 6, we are getting 13, and this is our answer here. Okay. So, what should we do to get the Excess-3 code? So, to get the Excess-3 code, just subtract 3 or equivalent of 3 from the sum. So, what is the equivalent of 3? So, this is the Excess-6 code, 6 code, okay, for 2 plus 5. Okay. If you will subtract the equivalent of 3, equivalent of 3 is 0 0 1 1, we know from here. Okay. So, 0 1 1. So, we will subtract 1 minus 1, we know for the binary number 1 minus 1 is equals to 0. Okay. So, we get the 0 here, 1, this is 0, and if you want to subtract 1 from 0, that is not possible. So, to make it possible, we have to take a borrow from here. Okay. So, we get the borrow from here, and the borrow will be 2 to the power. So, if this is 2 to the power 0, this is 2 to the power 1, this is 2 to the power 2. So, we are taking the power 2 to the power 2, and the place value is 2 to the power 1. So, final we will get it 2, and if we subtract 1 from 2 minus 1 is equals to 1. So, that is why we are getting the, after subtracting from here we will get the 1 here, and this is, it will become 0. So, 0 minus 0 remains 0, and 1 minus 0 is equals to 1. So, this is the answer, and we can cross verify this answer, either this is Excess-3 code or not. Just convert this number to the decimal number from this. We know the weightage value of the for the final number. So, this is 1010, and this is 8421. So, from here we can see we have the 8 is high and 2 is high, 8 plus 2 is equals to 10, and if we will add, these are 2 plus 5 is equals to 7, we know that. So, 2 plus 5 is equals to 7. If we add 3 in this as per the access code requirement, for the access code is, if we add the 3 with the decimal number, we will get the Excess-3 code. So, okay. So, if we will add, this is 7 and this is, we final answer is 10, equivalent of 10. If we add 3 in the 7, we will get the same answer. It means our answer is correct now. Okay. So, the most important part of this question is, whenever you are going to add 2 digits, decimal digits, always remember we have to add the Excess-3 in the each digit, but whatever the answer we get in the end of the adding the Excess-3 codes, that will not be the Excess-3 code. It will depends how many digits you have added. Like here in this example, we have only 2 plus 5, it could be 2 plus 5 plus 7, something like this. So, if we are adding 2 plus 5 plus 7, it means we have to add the binary equivalent of 3 times. So, we will get the answer is Excess-9 code. So, that time we have to subtract how much? 6, okay, from the final sum. So, always remember how many times we have add the binary equivalent of 3, okay, and in the final answer we want only 1 times 3, because in the Excess-3 code only add whatever the binary whatever the decimal numbers, we have to add just 3 one time. Okay. So, I hope you understand this question. Because the addition of 1 bit to decimal numbers using Excess-3 code. So, in this example I have taken the 2 bit 2 decimal numbers, and I want to discuss about the addition of these two numbers using Excess-3 code. Okay. So, as per the rule number 1, if you want to add two decimal number using Excess-3 code, so first of all we will convert the decimal numbers to the binary coded decimal, means BCD code, and then we will get the Excess-3 code after adding the binary equivalent of 3 in the BCD code. Okay. So, as the BCD code represent each digit of the decimal numbers in the 4-bit code, and the 4-bit code their value is standard is 8421. It means the maximum possibility means this is the weight for each weight standard for the BCD code if the code is not given. This is by default. So, if we want to write down the BCD code for 27, it means we have to write down the 4-bit code for 2 as well as 7. So, the BCD code for 2, from here we can see if we want to get 2. So, this it should be remain 0, it should be 0, it should be 1, and it should be 0. Okay. So, the BCD code, this is the BCD code for 2. Okay. So, that is why I write down 0010. Okay. Now, I want to write down the BCD code for 7. So, BCD code for 7, from here we can see if I will make 0111. So, it will be BCD of 7, because 4 plus 2 plus 1 is equals to 7. Okay. So, this is the BCD code for 7. To get the Excess-3 code, what we have to do? We have to add the binary equivalent of 3 in both the digits. So, if we will add the binary code of 3 with this one, so it will become 0010. We will add 0011, then 1 plus 0 is equals to 1, 1 plus 0 is equals to 1, 1 plus 1, the sum will be 0 and carry will be 1 and then 0. So, that is why I write down the Excess-3 code of 2, and this if we will add 0111 and 0011. So, we will get 0 1 0 1, and this is the Excess-3 code for 7. Okay. Similarly, we can write down the BCD code for 39. So, this is 3, because first of all we will write down the BCD code for 3, then we will go for write down the 4-bit BCD code for 9. So, this is the BCD code for 9. From here we can see if I will make it 1 high 0 0 1. So, this is 8 plus 1 is equals to 9. Okay. So, this is the BCD code for 9. Okay. To get the Excess-3 code of 39, we have to add 3 in binary equivalent of 3 in this one as well as in this one. So, if I will add 3 here, so this is 0011, 0011, then 0 1 1 and 0. So, this is the Excess-3 code for 3, and similarly we can get the Excess-3 code for 9. If we will add 0011 in this, we will get 1 plus 1 is equals to 0, 1 plus 1 plus 1, because 1 will be the carry, 1 plus 1 is equals to again 0, and this is 0 plus 1 is equals to 1, and 1 is directly. So, this is the Excess-3 code for 9. Okay. So, to get the addition, what we will do? We will add these to Excess-3 code. So, as there are 2 columns from here, so we can make it group 1 and group 2. So, from here we can see this is, I have put it in group number 1 and this is group number 2. So, group 1 represent these bits, the Excess-3 code for 7 and 9, and group 2 represent the Excess-3 code of 2 and 3. Okay. So, to make it more understandable, we can write down it like this, and if we will add these 2 numbers. So, 0 plus 0 is equals to 0, 0 plus 1 plus 0 plus 1 is equals to 1, 1 plus 0 is equals to 1, 1 plus 1 will be, sum will be 0 and 1 carry, and this carry will go here. So, 1 plus 1 plus 0 is equals to 1 plus 1, and then 1 plus 1 we know sum is equals to 0 and carry is equals to 1. This carry will go here, and this is 1 plus 1 further, we get the sum is 0 and carry is 1. This carry will go here, 1 plus 1 plus 1. In case of 1 plus 1 plus 1, we get 1 sum and 1 carry, and this carry will go here, and this carry will be copied directly, because the remaining 2 digits in this column is 0 0. So, 1 plus 0 plus 0 is equals to 1. So, we get this one. So, from G1 group, actually from the G1 group, the final carry we get in the, when we add 1 plus 1, okay, 1 plus 1, we get the sum is 0 and we 1 carry produced, which is this one. Okay, 1 carry produced. So, add 0 0 1 1 means binary equivalent of 3 with this group, whatever the sum we achieve from the adding these 2 numbers, add 3 in this one. Okay. So, the sum from this one is this is. Okay. So, group, the sum of group 1, if we will add 3, we will get the final answer. Okay. Now, this is 1, this is the, in this case in G2 the final carry is 0. Okay. So, if the final carry is 0, subtract 0 0 1 1. Okay. So, that is why if we want to get the final answer access in the form of Excess-3 code, we have to subtract binary equivalent of 3 from this number. So, that is why I have subtract from this, okay, and add in this one. Okay. So, now let us do it. So, here we can see 0 plus 1 is equals to 1, we know that. 1 plus 1, the sum is 0 and carry is 1. This carry will go here, then 1 plus 1 plus 0, the sum will be 0 and carry will be 1. This carry will go here, this carry will go here, and 1 plus 0 plus 0, the sum will be 1. Okay. Now, from this 0 plus 1 is equals to 1, 0 plus 1 is equals to, it should be 1, and 1 plus sorry. So, in this column, this is the sum of these 2 numbers, and in this, for this column, because for the group 2 the final carry is 0. So, we are going to subtract. So, if we will subtract 0 0 1 1 from 1 1 0 0. So, what will we get? So, this is 1, 0 is less than 1, it means we have to take borrow, but this is also 0. So, we will take the borrow from here and then from here. So, this will become 2, because this is based on the 2 to the power 1 we are getting whenever we will borrow it. So, it will become 2 to the power 1 and that is equals to 2. Okay. So, 2 minus 1 is equals to 1. So, we will get the is 1. Okay. Now, here 1 will remain. So, if it will become 1. Okay. So, 1 minus 1 is equals to 0 and it will become 0. So, 0 minus 0 is equals to 0 and this is 1, 1 minus 0 is equals to 1. So, this is the final answer and we can verify it either this is correct or not. So, 27 and 39 we will add it in the decimal number system. So, 16, 6, 5 and 6, 66. Okay. So, if we add 3 in both the numbers, so what we will get 66 3 plus. So, we get 9. Okay. And this is from here we can see this is the Excess-3 code of 9, this is also the Excess-3 code of 9. It means our answer is correct. Okay. So, these are the questions. Add the following numbers using Excess-3 code. So, these are this is the assignment 8 plus 9. What will be the answer? Second one is 23 plus 33. What will be the answer for this? And this is 3 plus 11. So, in this assignment I have covered both type of Excess-3 addition, means one digit when both the numbers are single digit, when both the numbers are two digit, and one number is single digit and second one is double digit. Okay. So, now next topic is cyclic code. Cyclic code, it is also known or gray code, we called it gray code. So, gray code is also known as cyclic code. It is unweighted code like a BCD code. In the BCD code, each digit has their weightage like 8, 4, 2, 1 if standard 1 is. So, like if we have a 1, 1, 1, 1. So, it means this 8, 4, 2, 1. So, this one has the weight of 8. Okay. So, this is not in the cyclic code. Unit distance code and minimum error. So, this is used for the error detection, and it is also because this is it will go the only one bit 1 unit distance will be changed whenever we will get the next one. It is also known as reflected binary code or RBC, also known as gray code because it was proposed by Frank Gray. This is the name of the scientist. Based on this, on the scientist name, the name of this code was appeared, and two successive values difference is only 1 bit. Okay. The binary number is converted to gray code to reduce the switching operation. So, this is used for the switching operations, this code especially for the switching applications, and it is used in digital communication to reduce the error. Okay. From here you can see this is used for to reduce the error. Okay. So, let us take an example. If we have a binary code and we want to get the gray code. So, if this is our binary code 1 0 like 1 0 1 1, this is our binary code and we want to convert it to the gray code. So, how we will handle it? So, first of all we will write down this number 1 0 1 0 1 1. Okay. So, what we will do, the first MSB rule number 1 for this, MSB write as it is, means we will not do any change in the MSB, most significant bit, and this is LSB. Okay. So, MSB will write down the as it is, add MSB in the next bit and neglect the carry if produced. Whenever we will add the MSB of the binary number to the next bit, means like in the bit here, and we are not going to change anything. Okay. So, and we can also represent it as XOR gate or adds detector, adds one detector. Okay. So, from here we can see we will just copy 1 as it is here. Okay. In the next case, what we will do? We will add MSB in the next bit, or next bit is, if we will add this one 1 here. Okay. So, 0 plus 1 is equals to 1, we know in the binary code. 0 plus 1 is equals to 1, 1 plus 0 is equals to 1, and 1 plus 1 sum will be 0 and carry is 1. This is sum. Okay. And in this case, the neglect the carry, we do not care about the carry. Okay. So, 1 will be copied as it is from rule number 1, from rule number 2 add these. So, 0 plus 1 we get it, 0 plus 1 is 1. Okay. Now, add this bit to the next bit. Okay. So, next bit is 0 and the next bit is 1, this one. So, 1 plus 0 is equals to 1 from here. Okay. So, we get the 1. Now, add this 1 to the next bit, and next bit is 1 also. So, 1 plus 1 plus 1. Okay. So, 1 plus 1 we know the sum is 0 and neglect the carry. So, we have neglect the carry part. So, this is the gray code. Okay. And the order will be G3, G2, G1 and G0, similar to the here B3, B4 as it is. Okay. Now, binary, this is the table, either this table will be occurred from the same, using same example we can get any table. So, like 1 0 1 1. So, we can get this table also. If we have decimal number is, decimal digit is 0 and we want to get the binary code. So, the binary code will be 0 0 0 0, because we know the 0 plus 0 plus 0 plus 0 is equals to 0. Okay. So, decimal number 1 and binary code will be 1 1 0 1 1 1 0 0 and 0 1 0 1, because we know from 8 4 2 1. Okay. So, from here we can get the binary code for different digits, and 4 to 16 32 like this for the, and from this conversion we can, using this one we can get the gray code for all the binary numbers. Okay. Or whatever the binary code is there, we can get the gray code, like for here like 0 0 0 0, as per rules the MSB will copy it as it is and we will add it to the next one. Okay. So, plus 0, this will be one copied here. So, what 0 plus 0 is equals to 0 plus 0 is equals to 0. So, we will get it 0. Now, this will go here plus 0. What will be the answer? 0 plus 0 is equals to again 0. This will go here plus 0 and 0 plus 0 is equals to 0. That is why we get the gray code is 0 0 0 0. Okay. Similarly, if we want to get the gray code of like 1 or 2, we can discuss about this one. So, the binary code is 0 0 1 0. Okay. This is the binary code for 2. Okay. We want to get the gray code. So, MSB will be copied as it is, then this will go here 0 0 plus 0 is equals to 0, this will go here plus 0 is 1 plus 0 is equals to 1, and this will go here plus 1, 0 plus 1 is equals to 1. So, it will be the gray code, and here we can say. Okay. So, 0 0 1 0. In this way we can make this table for up to 16 or higher number. Okay. Now, I have discussed about the conversion from gray code to the binary conversion. So, now I want to convert the gray code to the binary. In the previous case I have discussed the binary to gray code conversion. Okay. So, if we have a gray code, then how we will get the binary conversion, okay, binary number for the given gray code. So, for example, if we have a code 0101, okay, and we want to, this is a gray code, okay. So, 0101. So, G3 as per rules, G3 will be copied as it is, okay, and this whatever we will add, this G3 will go to the next bit of the gray code, add to the next bit of the gray code. So, 0 plus 1, we know 0 plus 1 is equals to 1. This one will go to the add to the next bit of the gray code. So, 1 plus 0 is equals to again 1, okay, and this is 1. This one will go add to the next digit of the gray code. Okay. So, 1 plus 1 is equals to, sum will be 0 and carries, we will not consider the carry. Okay. So, the gray code, the binary code will be 0 0 1 1 and 0. So, the binary code for this gray code is 0 1 1 0. Okay. So, from here we can even cross verify either it will be correct or not. So, like 1 0 1 1 1, if this is the binary code and we want to convert it. So, this will be copied as it is, this will add here plus 0. So, 1 plus 0 is equals to 1, this will go here plus 1. So, 1 plus 1 is equals to 0, carry neglectable, this will go here plus 1, and 1 plus 0 is equals to 1. You know this is code, and it was the same code. From here we can see 0 1 0 1, it means our answer is correct. So, thank you very much for your attention. If you have any query, you can write down an email to me rajeevnitj@gmail.com.